Something is going on with the weather. In the late winter of 2019, 14 U.S. states from North Dakota to Louisiana are smothered by an historic flood. A flood that usually happens in spring.
I lost everything.
1 month later, a severe winter storm slams wide areas of the high plains, spreading deep snow, stranding people and livestock. A winter storm in spring. Then, in April and May, a severe tornado outbreak in the Central Plains spins up over 500 twisters, killing 13 people and flattening towns from Texas to Iowa. Extreme weather events just keep coming. More, bigger, more often. And the question at the top of everyone's mind, are these the real impacts of a warming planet?
This is more than an extreme weather story. This is a story about our food and our water systems. This is a story about our health, our economy, our buildings, our roads. This is a story about our sports, our tourism, our ways of life. And climate change is not this thing that's going to happen in the future and we need to just prepare for. It is happening right here and right now in communities across the country.
There is zero debate within the scientific community that the planet is warming. That's unequivocal. It can't be denied. The instrumental record gets really good at about 1950, and it gets even better after that when we put satellites into space and we can now make comprehensive measurements of the globe at a rapid frequency. And these are all telling us the same thing, that the planet is warming. It's warming from the top of the atmosphere to the bottom of the oceans.
But how do we know all of this for sure? All across the world, thousands of weather stations record temperature, rainfall, and wind. The results of this simple record keeping are straightforward. 2018 was Earth's fourth warmest year on record, after 2015, 2016, and 2017. 9 of the 10 warmest years since 1880 have occurred since 2005. 2019 is on track to be in the top 3 warmest years on record. What's more, the global climate is responding to all that heat.
Global warming is affecting different kinds of weather in different ways. The easiest one for everyone to understand is that you add more heat, you're going to have more heat. Temperatures are higher, heat waves are lasting longer, they are more intense, and we're seeing more of them. But some other ways that we're seeing our weather change is the increase in extreme amounts of rainfall. And this is happening around the globe, even in places that are drying out. You have to look at our world as a water world. So when you take a world that is mainly water, you evaporate that water into the atmosphere, there's more of it to actually come down in these heavy rainfall events. And that is what we're seeing everywhere.
In 1859, Irish scientist John Tyndall discovered that carbon dioxide, methane, and water vapor all trap heat in the atmosphere. 40 years later, a Swede, Svante Arrhenius, predicted that carbon dioxide from fossil fuel combustion might boost that warming and coined the term greenhouse effect. Tyndall and Arrhenius were right. Now the planet is warming, and for the reasons they discovered. However, what no one back then could predict is how atmospheric warming might change the way weather behaves. More than that, how it would force a shift in the global climate and change the weather, not just for today or tomorrow, but permanently.
You often hear people say, so what's the big deal? Climate has changed a lot in the past. Well, yeah, we know that because climate scientists have figured out how climate has changed in the past, and that's why we're so concerned, because the changes we're seeing are far outside of what we would consider natural variability. If we compare the future expected changes, right, we're talking over the next several decades of a few degrees Celsius, maybe 5 degrees Fahrenheit. Changes of that magnitude in the past have completely reorganized Earth's climate. So we're talking the difference between a deep ice age or a very warm greenhouse Earth, changes of this magnitude. And if we continue to put emissions into the atmosphere, we expect to exceed the changes that we've seen in the historic record and basically put us back to climates that were present when the dinosaurs were roaming the Earth and there were crocodiles near the North Pole and that sort of thing. So, a couple of degrees Fahrenheit globally is a massive amount of climate change.
It sounds like an extreme future, but scientists base it in part on the record of how the climate has behaved in the past.
Before the mid-19th century, we can use what we call climate proxies to try to reconstruct what climate was like. Things like tree rings, things like ocean sediments, things like ice cores. From that record, we can rebuild climate patterns on the order of centuries ago to millions of years ago, and those are all telling us that we're in a period of unprecedented warming that can't be explained in any other way except through greenhouse gas emissions.
The growth rings of old trees report hot and cold, wet and dry periods going back hundreds of years. Ice cores drilled from the bottoms of glaciers contain bubbles of the atmosphere as it was hundreds of thousands of years ago. Ocean sediment cores push the climate record back even farther, to many millions of years. Forensic analysis of all these so-called paleoclimate models together tells the story of a climate that has changed naturally through time. Variations in the orbit of the Earth, sun cycles, volcanic eruptions, and other natural forces have all played a part in changing the climate. But there is one consistent common theme. When carbon dioxide levels have been lower, temperatures have been lower. When carbon dioxide levels have been higher, temperatures have been higher.
So going forward, what we can expect, unless we do get a handle on our emissions that we're putting into our atmosphere, is more extreme weather events, including heavy rain, including intense heat and intensifying tropical systems. We're also going to expect rising seas at an increasing pace, melting ice from land ice, from glaciers, and our sea ice not reforming the way it has in the past. And one thing that people don't always think through is that these increases aren't going to happen in a bubble. These increases are going to happen at the same time.
Different kinds of extreme weather do seem to be happening all at once, on TV at least. But people who get hit by big floods, fires, hurricanes, tornadoes, and heat waves are not the only people being affected by warming and the changing climate. The climate is changing everywhere, all the time.
So to help people better understand the magnitude of the changes we're expecting, we created this Future Urban Climates Mapper. It's a web application that people can go to and look at any one of about 540 urban areas in North America to see how climate change is expected to impact these places. So people can go to this application, they can click on an urban area and see where the current climate is most similar to that urban area's future climate. So a great example is Washington, D.C. By 2080, Washington, D.C. is going to feel like a town in northern Mississippi that's called Greenwood, Mississippi. So the typical winter in Greenwood, Mississippi is about 10 degrees Fahrenheit warmer than D.C.'s winter is at present. That's about 5-6 degrees Celsius. And it'll be 75% wetter in winter in Washington, D.C. than it is now. So it's going to become more subtropical, in essence. Children living in Washington, D.C. today, if they continue to live here, they're going to live through a dramatic transformation of climate. They'll be telling their kids what climate was like, and their children aren't going to believe that it used to snow potentially in Washington, D.C.
Run the clock forward 60 years, and all the changes taking place now have added up. By 2080, weather in Miami will be more like southern Mexico. Minneapolis, St. Paul will be more like Nebraska. St. Louis and Denver will be more like northern Texas. The point is, the climate is already moving in these directions.
Climate change is affecting everyone here and now, just in different ways depending on where you live. In the West, droughts are getting worse. That's upping the risk for wildfires, and that is worsening air quality. What we're seeing in the middle of the country, intense heavy rain events, particularly the Midwest, where there's a huge uptick in these heavy rain events, which are wiping out crops for farmers and really interfering with the timing of planting crops and harvesting crops. Across the South, intense heat is getting more intense and it's lasting longer.
While extreme weather events increase in number and strength, and the growing heat breaks new records yearly, NASA, NOAA, and national agencies around the world are keeping a close watch. NASA has 16 satellites collecting long-term data on changes in ocean evaporation, atmospheric water vapor, clouds, sea and land ice, snow cover, and other aspects of the global climate. The growing evidence gives a good picture of what's happening on the planet. The world is getting warmer, and the climate is steadily changing.
The natural world is a really good place to look for these changes that are going on because a lot of aspects of the natural world are responding, whether it be on land and fresh water or in the oceans. And so what we're seeing is earlier greening in spring, early arrival and singing of birds, earlier first singing of frogs. We're seeing species shifting their geographic ranges to the north, so species that previously were limited to southern locations are slowly marching forward.
One of the biggest impacts from all the warming is on the plant world.
This represents these enormous, very visible shifts in our climate that are changing right in front of our eyes. This is a USDA map showing the ideal areas to plant certain crops, and they're color-coded. Now, the first image you see is 1990. I'm going to put it in motion here, and it'll jump to 2015, and look at this enormous shift in the areas where we ideally want to plant crops. All of that is based on temperatures and rising temperatures.
In just 25 years, there's been a major shift in where plants can survive and thrive. The heat is moving north, and the plants are moving with it. The question is, will they be able to adapt to such a rapid rate of change?
The real problem, I think, is related to our ability to grow food and extended drought. And maybe in places like eastern North America that are predicted to become wetter, that's not going to be as big of an impact. But globally, large-scale drought is going to force people to migrate to new regions. That's going to destabilize regions, and we're going to have climate migrants. And I think that's probably one of the biggest near-term impacts. We focus on natural systems or things like that, but these impacts to societies are going to be very large, and they're going to ripple across the planet.
A record-breaking Japanese heat wave in May, temperatures over 100 degrees Fahrenheit. Western Australia had its warmest January on record with temperatures topping 120. All across South America, heat records fell. The Atacama Desert, one of the driest places on Earth, flooded. The growing heat, stronger hurricanes, long droughts, flooding rains, intense heat waves, rising seas. Is this really our future? Unless the world can bring down greenhouse gas levels in the atmosphere, now at 415 parts per million, the overwhelming scientific evidence says, get ready for even more life-changing, extreme weather events.
My goal would be to take our efforts and expand them globally to do potentially thousands of urban areas across the planet on all of the continents where lots of people live, to try to get everyone across the planet better informed about why we're concerned.
One of the biggest things people can do is talk about climate change and ask questions so that they can understand that their actions have impacts. And the more you learn about the subject, the more you're going to understand how your personal actions are impacting our planet.